Hi guys, so today we're going to follow up a little more on ellipses. So let's say I ask for the standard equation of an ellipse and the center given is at the origin. So the center is at 0, 0. Mind you, this will be a sketch because the horizontal major length of axis is 40. So yeah, just pretend it's symmetrical. So this would be from 0 to 20. This would be from 0 to negative 20. And I know this because the length from here to here would be 40. There is a vertical minor length of axis of 10. So that means the length from one co-vertex to the other co-vertex is 10. So that means this would be 5 and this would be negative 5. Now, doesn't look symmetrical at all. But keep in mind that the horizontal major length of axis given in the other ellipse video has the length 2a. So if it's not drawn symmetrically, you can't really see what's going on, you can always solve it algebraically as well. And the vertical minor length, the minor length is represented by 2b. So I could just solve this algebraically as well. So since 40 equals 2a, that means if I divide each side by 2, half of that, a would be 20, which is also what I wrote graphically, even though it doesn't look that way, from the center to the vertex. The distance of a is 0 to 20. I'm sorry, the distance is 20 because it goes from 0 to 20, and other side as well. And from the minor length, if I wanted to solve that algebraically, I have 10 equals 2b. So I would just divide both sides by 2, and b would equal to 5. So the value of a and b are always half that of the major and the minor axis because I'm going from the center to the end, whereas the major and minor go from end to end. So if you see here as well, the distance from the center to the co-vertex would be 5 as well in order for it to be a full distance of 10. So we have A, we have B, we have the origin, which represents the center. So I think that's all we need in order to write the standard equation. We just have to know which equation to use. And again, it has a horizontal major. So we know that the larger denominator, or A, squared will be under the x because horizontal correlates with the x-axis, plus y minus k squared over b squared equals 1. So filling in the values, if I replace the h and k with 0, x minus 0 is x, so I'm just going to write x squared, and y minus 0 is also y, so I'll just write y squared. A squared, well, a is 20, so 20 squared, and b is 5, so 5 squared equals 1. And there's my equation. All right, guys, hope this helps.